humid climate like we have here in Pennsylvania, carbonate rocks essentially dissolve over time. Out west in New Mexico, limestones are ridge formers. Back here in the east, they're normally underlying or within the valleys. And that's because rainwater, which is naturally acidic due to carbon dioxide in the atmosphere, will slowly eat away at the calcium carbonate, which is the predominant mineral in these rocks. As these rocks eat away, you get voids, opening, there's fractures in these rocks to begin with. Those fractures are enhanced. It's called solution enhancement due to the slightly acidic water making these cracks a little bit bigger and a little bit bigger. Maybe you'll get a conduit. Maybe at some point it might turn into a cave system in some areas. But one of the things you also get in these areas are sinkholes. This is from over around Hershey, and obviously when one of those sinkholes, actually the sinkhole, these sinkholes aren't formed by the rock all of a sudden dissolving. The rock's been dissolved. They're just filled in with sediment. Something causes that sediment to move out of the throat of it. Usually it's related to either a rain event or a flood, or in this case, you'll notice that there's a sewer manhole there. If that sewer line was leaking, that could have been the cause of adjusting some of that subsurface material that allowed a whole bunch of the soil and clay to move down and settle within that depression, thus causing that sinkhole. Obviously, you can see how a type of rock like this would transmit large amounts of water, and it could be a very valuable resource for trying to develop a water supply. On the other hand, because it is so much easier to exchange water with the surface, it's very susceptible to contamination. So limestone areas generally are good for developing water supply wells, but you have to be very careful with the quality because they're highly susceptible to contamination. Speaking of contamination, let's talk about some of the land use impacts on water quality. Virtually everything that goes on at the surface has a potential for affecting water quality, whether it's groundwater quality or surface water. These things could affect both surface water and groundwater. Things like landfills, where you could have organic materials, metals, chlorides are generally a good marker for landfills also. Housing developments, you might not think, well, where I live is a source of pollution, but if you consider if there's a lot of septic systems, if there's high densities of septic systems, where there's leaking sewer lines, you could have issues with bacteria, perhaps nitrate. Obviously, there's stormwater considerations in places like this, so you might have to worry about sediment moving around during construction activities. And also, a lot of people like to have nice, green, thick lawns. I don't. I hate mowing grass, so I never put anything on mine. I absolutely hate mowing grass, so I'm never going to put fertilizer on it. But a lot of people do like that, and I've even seen figures that suggested that the usage of fertilizers, and sometimes, I guess mostly fertilizers, not so much pesticide, but the use of fertilizer is actually higher per capita in some urban areas than it is in farming areas, and that's due to over-application. There's this mindset out there that if it says to use, 100 pounds per square, 100 square feet or whatever, well, if I use twice as much, it's going to be twice as good. Well, no, that stuff's just going to run off, get into a waterway, or possibly contaminate groundwater. If it gets into a surface waterway, it's going to eutrofy that waterway. You're going to have algae growing. It's going to reduce the dissolved oxygen. It's going to cut down the light. It's going to mess with the plants that are trying to grow. Ultimately, it's going to affect the fish and the aquatic organisms. Even transportation corridors can be a concern. Obviously, in the winter, de-icing activities involving salts can be a source of contamination. And it's not uncommon to have accidents, particularly with trucks that are carrying Lord knows what on these roads. So you always have to be concerned about that. not just transportation corridors in terms of roads, but also rail lines. You'd have the same thing to worry about, and possibly even pipelines might fall into that category also. Industry, of course, can be a source of contamination. Organic compounds like volatile organic compounds and petroleum are probably some of your common contaminants with that. And agriculture at times can be a source of pollution from ag runoff, and the main concerns there would be bacteria, nitrates, and pesticides. A lot of places, especially where they grow corn, they use a lot of the triazine compound pesticides, and they sometimes use a lot of them, and they sometimes find that working their way into groundwater. Mining, it's probably not as much of an issue around here. We have limestone quarries or aggregate quarries, so we don't have to worry about some of the issues with acid mine drainage like they do in the northeastern part of the state or the western part of the state, where you have to worry about this really low pH water leaching metals out, basically killing your streams. And if anybody's ever been like up around Johnstown or some other areas where there's legacy coal mining, and you've seen the dead streams that are just coated with the orange yellow boy, they call it. I first saw that. I went to school in Johnstown for my undergraduate degree, and I'd never seen anything like that. One of these streams where like there was nothing in the water, it was very acidic, and the entire stream bed and all the rocks were coated with this nasty bright orange rust-looking material. It's really probably between acid mine drainage and ag runoff are probably the two biggest sources of contamination to groundwater in Pennsylvania. Another thing you might hear about these days is what's referred to as emerging contaminants or contaminants of emerging concern. These are various different substances. Some are organic wastewater constituents. Caffeine can be one. Some of them are pharmaceuticals, over-the-counter products. Some of them could be the fragrances that are in various health and beauty aids, soaps and things like that, personal care products. Turns out these things apparently have an effect on aquatic organisms. We're not sure, though, what they do to human beings. We don't have any documented evidence because there hasn't been enough study. They haven't been looking at this long enough to find out, is this really a concern for human beings? But people are kind of leery when you think about the possibility of drinking water that has a cocktail of low-level different constituents in it. And a few years ago, the Associated Press ran a big story about, they sampled drinking water at a bunch of major drinking water supplies in the U.S., and lo and behold, they found residues of pharmaceuticals in that water at very, very, very low levels, much, much lower than what the therapeutic doses are, but nonetheless, that material's there. And as I indicated, we do know now that they're affecting aquatic organisms. You get things like intersex fish and things like that. It was a big deal down in the Potomac River a few years ago. And as a result of that, one of the things they thought is that, well, we should try to make sure that people are properly disposing of pharmaceuticals in an environmentally safe manner. So, and this was actually spurred by the Drug Enforcement Administration, because their concern is they want to prevent drug diversion. They don't want kids and other people or whoever getting their hands on discarded drugs. So with DEA's help and with EPA and some other environmental groups and water suppliers and other folks like that piggybacking on this, DEA has started these national take-back events. They've had 5 of them so far since fall of 2010. The last one was in the end of September, and they collected 244 tons of unused, unwanted pharmaceuticals and over-the-counter medicines. For those 5 events combined, they've collected over 1,000 tons of this material. So at least we got this out of the water stream, because unfortunately, prior to this, the common guidance for disposing of these things was flush it down the toilet or throw it down the sink. Well, now we know that's probably not a really good idea to do. We don't really have a good handle on how much of the compounds that we are detecting in waterways are actually related to improper disposal, because a lot of it still comes from wastewater plants. Apparently, a lot of pharmaceuticals aren't metabolized completely in your body, so when you excrete them, they end up in a sewer plant or a septic system, and they will find their way to a waterway. But at least this is one way where we're getting people to think about what you should do with these, and at least minimizing any additional impact by people flushing these things down the toilet. DEA is actually working on regulations right now that would allow people to properly dispose of controlled substances. Right now, the issue with drug take-back programs is if it's a controlled substance, the only person that's allowed to possess that controlled substance is the person who has the prescription. So it makes it really difficult to return these things that are controlled substances. Not every pharmaceutical, of course, is controlled substances, but these controlled substances are the ones that DEA is most concerned about for preventing diversion. So they came out with guidelines where, A, let's not flush these things anymore. I think there are still like maybe about half a dozen drugs that for whatever reason, and off the top of my head, I don't know what they are, but there are still about half a dozen to 10 drugs that they still say the best way to get rid of them is flushing them. But everything else, they say, should go to, should be inerted with something like coffee grounds or kitty litter and thrown in the trash rather than ending up in a waterway. So DEA is working on these rules where they're going to be able to have things like the state of Maine has, where they have a mail back program where you can actually mail back your unused drugs, get them out of your hair that way, or just take them back to a pharmacy and drop them off. Right now, unfortunately, everywhere else but Maine, and the only reason Maine can do it is because they actually have a state version of the Drug Enforcement Administration, and they cleared all this. The only way you can get rid of these things is to give them to a law enforcement officer. So until DEA comes out with their rules on this, they're going to keep having these take-back events twice a year, and I anticipate the next one to be sometime probably in April or May of 2013. So I just wanted to mention that. I'm not trying to scare anybody, but just want to mention that that this is one of the hotter topics that you hear about right now in terms of water quality protection, or these emerging contaminants. Now, of course, this will take care of the pharmaceuticals, but there's still, all the other issues from the various chemicals that we use, like in shampoos and deodorants and things like that. So obviously, this isn't the end-all, be-all, and there's some more work we need to do. So let's take a look at some of the water quality in some of the streams here in the area. And here we have a map depicting stream quality in Franklin County, and the impaired water bodies are in red. And I would imagine, just like in Cumberland and Adams, that the majority of these impaired waterways are as a result of agricultural runoff. So this is just sort of to give you a graphic idea as to where these impaired water bodies are within Franklin County. And we can take a look at them here in Cumberland County. In this particular one, any of the colored stream reaches are impaired. There's 231 miles of impaired streams in Cumberland County. Their largest source, agriculture, 109 miles. And in Adams, kind of the same picture, 277 miles of impaired stream. The largest source and cause is agriculture and siltation, about 200 miles of that. So the vast majority of impaired waters in Adams County is related to agriculture. Let's take a look at groundwater quality in the area. And this is depicting nitrate concentrations in groundwater wells in the lower Susquehanna West Basin. And it's color-coded this way. If the dot is green, it was 0 to about 5 parts per million or milligrams per liter nitrate. If it's yellow, it's 5 to 9.99 milligrams per liter. If it's red, it's 10 or above. 10 milligrams per liter is the drinking water standard for nitrate. Nitrate is primarily a concern for children and for pregnant women, although there is some evidence that it might have a role in causing some types of stomach cancer when it gets reduced to nitrites in your stomach, and could possibly be involved with forming some type of cancer there. But this gives you a depiction of what we're looking at in parts of Adams, Cumberland, and a little bit of Franklin County related to nitrate distributions. You can see, fortunately, there's not a whole lot of red ones, but there are some around. And again, we can look at the same data, except for the Potomac Basin in Pennsylvania. I want to mention that DEP does have an ambient groundwater monitoring program, but it's limping along. There's only about 4 basins being monitored. Most of those are in southeastern Pennsylvania. So it's unfortunate that the department itself is not collecting a whole lot of ambient groundwater data. Because we're hampered and don't have the resources to do that, we've partnered with the U.S. Geological Survey to come up with a compilation of all the groundwater data, basically, that they could get their hands on from 1979 to 2006, and they published 2 different data series reports. So this one is from DS 150, Data Series 150. It's available online. This was the first version. Then that was subsequently updated a few years later, and that report is DS 314. But if you're looking for anything related to actual groundwater quality data in Pennsylvania, those 2 reports are like the Bible of current knowledge related to groundwater quality in Pennsylvania, and they are available online. One of the issues with groundwater is, unfortunately, Pennsylvania is one of 2 or perhaps 3, depending on how you count it, states that do not have statewide construction standards for private on-lot wells. I don't know why. It's been introduced several times. It never seems to come about. So there's a political component involved. But the good thing is, legislation was introduced in this past legislative session. It didn't make it out of committee, but it's going to be reintroduced in the next session. And believe it or not, one of the things actually driving it is some of the pre-drilling sampling that's being done in the Marcellus areas. The gas companies and the others that are doing the pre-drilling sampling of homeowner wells are finding that, hey, there's some water quality problems associated with this, and believe it or not, that's probably going to drive us towards finally having water well construction standards. The problem is, in Pennsylvania, without these construction standards, wells do not have to be grouted. Grouting a well involves when you drill a borehole into the earth and jam a piece of metal casing in there, there's going to be a slight, very, very small gap between that metal casing and the borehole itself. That material needs to be grouted or sealed up with some type of impermeable material. That prevents any kind of surface water contamination from directly migrating down along the casing and getting in your well. So it's basically a nice, good sanitary seal. In addition, the well should probably have a little bit of ground sloping away from it. You should have a vented, sanitary, waterproof, vermin-proof cap, and it should be sited appropriately and far enough away from potential sources of pollution. Right now, since we don't have any statewide regulations, unless you're in Chester, Bucks, or Montgomery, which actually have regulations developed through their health departments, you could put a private well in anywhere. It's kind of weird. We have regulations related to where you can place a septic system, but it doesn't work the other way. You can't put a septic system within 100 feet of a well, but you could put a private well right beside your septic system, although I would hope that the SEO or somebody involved at the local level would talk you out of that, but theoretically you could do that. A few years ago, the USGS